So we basically have our tests working for our deposit token now, and we have the ability to deposit. Let's now create the functionality to reward and to issue tokens for people who are depositing. Like a bank, we want to say, we're going to do something where, let's say somebody deposits 20 tokens, they're going to get X amount back. If they deposit 40 tokens, maybe they're going to get more. We'll have an incentive. So if they deposit all their tokens, then they'll get the most amount back. If they deposit just one token, two tokens, we give them just a smaller amount back. Okay, so let's write some functionality to do that. So where would we do that? Well, if you guessed, in the decentralized bank Solidity contract, oops, not the JSON file, then you are getting this. All right, so let's go into our contract to central bank. And if you still weren't sure where that kind of logic would go, don't worry, it takes time and these things will start to click. So I'm going to scroll down, and we see we have our function here for the deposit token. So let's do the issue token. So issue rewards. All right, so we're going to create a function here called issue rewards, or issue tokens. It's fine. All right, and it's going to be visible, public. And the first thing I want to do, the very first thing we do before we issue tokens, I want to create a restriction. I don't want anybody to be able to use this function to be issuing tokens. We want to make it so that only who should be able to issue the tokens? The owner, right? Like, we should be the ones to issue the tokens. Makes sense. So let's require the owner to issue tokens only. Yeah. So we can just do that by typing in require Solidity. And what should we put in here? Well, we want the message.sender. We want the person who is in that instant calling on the contract to be the owner. The double equal sign is equal to, not to be confused with equal, which is something that equals something. This has to be the exact of what this is, which is the owner. Okay. And we can say here, we can write some kind of message. The caller must be the owner, right? Okay, great. So now we have that set up. Let's think about the actual logic. How can we do this? Well, let's just say theoretically, the way that we want to do this is that the owner can actually call this function whenever they want, depending on a schedule that they have, where based on that schedule, whatever is convenient for them, they can go ahead and they can issue tokens. And so what we can actually write here is a for loop. So a loop is something that can iterate through and make decisions based on what you imply, and you can create the parameters for the iteration itself. And we'll see what I mean by that in a moment. But essentially, we want to iterate through our array of stakers, and then we want to be rewarding our stakers that actually are staking, right? So we want to iterate through that and then reward based off of that. So we do that with a for loop. And if you're new to JavaScript, you're new to Solidity, it might look a little bit weird to see. It might be a little bit confusing at first to look at these for loops, but really, it's just a syntax that you kind of get used to, and then you see it so many times, and it's really not a big deal. But at first, it may seem confusing for sure. So just like with JavaScript, what you do is you type in for. And the only difference here is that we have to remember that it's static for Solidity, so we have to write uint. So we're going to say I equals 0. And so this is our starting point. So I starts at 0. Our first iteration's at 0. I should be less than stakers dot length. That's our array, right? So this is the point at which we stop our iteration. We go all the way through until the full length of I.stakers. And then what do we do after each iteration? Well, we can add another one to I. So we can say I++. Okay, so this is really a standard setup for a for loop, but you get used to it. If you're new to this, and it may seem a little bit weird. And what we want to do is we want to say that for our recipients here, we'll do stakers I, and our recipient's going to be address, right? So address, recipient. So each iteration of stakers is going to go to this recipient, okay, which is going to be an address. All right. So that's how we're going to keep track of each address. We're also going to create an integer, call it balance. And here we can say it's going to be the staking balance. Staking balance of the recipient. Okay. So we create balance, and then we set, so we create balance as an integer, and we set it to our staking balance of each recipient. And we set our balance to the staking balance of recipient. So essentially we're saying that how much do we reward them in our balance? Well, the reward is going to be the whatever it is, whatever was the amount that they were staking. That's what this is. So the staking balance of the recipient, the amount that the recipient is staking is going to be the balance that we return to them, okay? And finally, we can transfer the tokens by running the transfer function from our WD, right? Because we want to be sending them reward tokens. So reward, and we're going to send it to the recipient. And what is the amount? It's going to be the balance, right? Isn't that beautiful at the end there? We take the recipients, the stakers, right? And then we reward transfer the recipients and then for the amount, all in a loop. Very nicely done. Again, we're just reverse engineering what Greg wrote, but hopefully we're going through it step by step so you can really see the process here. It's pretty standard stuff, but very useful to learn, and to learn it like this, in my opinion. Finally, something that we can add is to ensure that the transfer happens only if the balance is greater than 0. We can write an if statement. We can say balance has to be greater than 0. Okay, and then we can make this transfer happen only if the balance is greater than 0, like this. And there it is. That essentially is our rewards functionality to issue rewards. So let's go over it again. So basically what we're doing here is that we create a function called issue tokens, which we can then access with visibility, which we can then access publicly. Then essentially we make it so that only the owner can call this, right? Because we only want the owner to issue tokens. And how do we actually go about the logic of iterating and issuing these tokens? Well, we make a for loop, and we set the loop to basically all the stakers in the array, and then we loop through it. Now, as we loop through it, we send a as we loop through it, we create we create recipients that go to an address, and they each take an I. All right, they all take an I. Then we set essentially a balance to the staking balance of the recipient, so the amount that they are staking. And finally, we say that if the balance is greater than 0, we're going to reward them what that is, and we use the transfer. And essentially, we transfer to the recipient the balance. We transfer to that recipient of the stakers the balance. Now, what if I wanted to create an incentive here? Well, let's say I don't want to give them that many tokens for starters. Let's say I'm like, well, I don't want to give them the equal amount of tokens, because this means that if they're going to stake 50 tokens, then they're going to get back 50 reward tokens. If they stake 40 tether tokens, they get back 40, all right? And so on and so forth. Well, what if I only want to give them 1/9 of that amount? No matter what it is that they stake, they only get 1/9 of that amount. Well, what we could do is we could actually, well, what would that do? Well, that would mean that if they were to stake 20 tokens, then they would only get, instead of 20 tokens, 2.2 tokens. I just calculated that on a calculator. If they staked 100 tokens, they would get like 11 tokens or something like that. So the more they stake, the more they're going to get back. So that's a nice incentive. So we're going to go ahead and say divided by 9. Okay, so we're going to save that, and now we've created our incentive, and we can even say divide by 9 to create incentive. for stakers. All right. To create percentage incentive. All right. Okay. So that's it then for the issue token. Let's go ahead and write some tests now to make sure that our issue token function is good. But actually, wait a minute. Before we do that, let's first just compile this down. Let's just compile this down. I know. I get excited. I want to rush. I want to rush to the next thing. But I don't want you to, I don't want to leave you stuck. I don't want to leave us stuck like last time trying to solve the truffle compile when we're already testing. So I'm just going to do a truffle compile now. And let's see what happens. Okay, great. So it says that it's compiled successfully. Good news. All right, so let's move over into our tests and write the tests that we need. So the first thing we want to do is just check that we can issue tokens here from the owner. So in order to do this, it could be a simple test. We can just say await, and we're going to go to central bank, issue tokens. We're going to grab that function, and we're going to say we want it from the owner. Okay, so that's going to run to check to see that this function we can issue the tokens from the owner. And then the other thing we should check is to make sure that only the owner can issue the tokens. So to do that, I'm just going to copy paste this. Here, let's bring that back and ensure only the owner. I don't know why I'm putting this all in caps. Only the owner. You don't, these are comments. You can just comment how you want. I don't know. I guess I've been doing this so that they're like titles, but usually you just write out sentences, right? Ensure only the owner can issue tokens. And so that means that if I were to switch this from the owner to the customer is not allowed to issue tokens, right? That would be bad news. So what would happen if I switched this to the customer? Well, then it should be rejected, and we can actually test this by using our should. So we should say should be rejected. We can type it in like that. So there it is. There's our dot should coming in handy. Let's put a semicolon. And let's save this and go ahead and run the test and see if it works. So we're going to go into our truffle and type in truffle test. Sorry, we're going to go into our console and type in truffle test. Enter. Yeah, so the caller must be the owner. Okay, so if we go back in our code into our decentral bank, we're going to see here that in my constructor, I don't actually set the central bank. I don't actually set owner to the message sender, right? That's where we want it to be. So what we're gonna do. So what we're gonna do is we're gonna add owner equals msg.sender. Okay. So I'm gonna save that. And now when we require it to be it should be able to recognize in our test that the owner, that it's okay to receive this from the owner. So let's go ahead and run the test again. So back in the console, truffle test. Okay, and now everything is passing. Excellent. So there we go. That actually would conclude our test for now for our issue tokens and for building out the functionality for issuing tokens. The only thing we really have left now is to do our unstaking, right? So we're able to stake and we're able to issue, but our customers or our investors aren't able to unstake. So let's go ahead and set that up in the next video, run the test for that. And after that, it's time to build out the application on the front end and hook all this functionality up so that it's user friendly and anyone can go on and with a click of a button start depositing their mock tether into our account. All right, that's exciting. Okay, that sounds pretty exciting. Great work. See you in the next video.